class. Okay, Assalamualaikum and very good morning to all. So I think we are 10 student or 9 student already in. So let's look at the yesterday task. Everybody submitted the task. Everybody submitted the task. Participant. Okay, in the chat, yes, no. If you don't want to unmute, I prefer if student bercakap lah. Okay. I prefer student to unmute mic. If you have mic, then unmute mic. If you don't, then chat. Right in chat. Don't. It should be a two-way communication. Okay. Yes. Semua dah. Alright. Thank you to all student. So let's look at this. Okay. Okay, there were some student. Okay, just look at this feedback form. Okay, there were some student commented. Please just ignore the name. Just look at the comment on what you don't understand. So there are students who mentioned that explaining about the filtering. Okay, and discussion on the amplifier in detail. Okay, like I mentioned just now, yes, lot of resources. So based on that comment, we are going to do some breakout session, but in a pair. So we have 10 student right now. So kalau 10 in a pair, 5 lah. But I think 9 student termasuk saya 9. So we do 4 group 4 groups. So what you are going to do the first one, before we go to the discussion of the problem 1, okay, before we go to this problem, okay, I want to guide you how to actually answer this problem 1. But before that, since some student commented that they are not sure about what is filtering, so let's do a breakout session in pairs. Okay, one group have 3 students later on. So the first one is that find the best video in YouTube, of course, representing filtering in signal conditioning. Okay, choose the video that reflect the content of textbook. Okay, so I already uploaded the chapter 3, okay, signal conditioning, right? So go look at the part where you have the filtering. So there are 4 main filtering. If you look at the notes, okay. So let me just open that note. Okay. Right. Okay, so let's open this. So we are going to look at where is the filtering topic. So that is op-amp. Op-amp. I'm sure in Polytechnic you already learn about this Tomoka Bridgestone semua. And for your information even though in the textbooks lots of things, but in the introduction to mechatronics, we are not going into depth in the calculation of amplifier. It's more on, if you look at it, is the principle or the fundamental theory of the amplifier. Okay, so calculation everything. Later you have another subject, analog. Analog. So analog subject, you will learn more on that, how to design the amplifier and so on. So at least in introduction to mechatronics, you know the concept. Tak ada.
It's at 3.4.
3.4. Sorry. Thank you. 3.4. Because my book is another version, so I think there's a 3.4. Very good, yeah. The student who commented just now. So I prefer student to comment like that. Okay, don't let me just scroll. I cannot find the topic. Yeah, 3.4, 3.5. Page, what page? 93. Okay, this one. Filtering. So you see, there are 4 main filter lah. Basically, low pass filter, high pass filter, band pass filter, band stop filter. Okay, so based on this, okay, actually in this part is that how to calculate the low pass filter and so on. But if you see, it's very because if you see in the book, it's very general. It doesn't show to you the calculation and so on. But in my slide, it's detailed. Okay, in my slide, if you look at my slide, if you go through my slide, if you went through my slide, in my slide, I have the detail on calculation of the low pass filter. Okay, so amplifier filtering, this one, So there are how to actually calculate for low pass filter. Okay, low pass filter, high pass filter, and so on. Okay, so based on this, so what the task is in a pair. In a pair, okay, find the 4, this one lah basically. Low pass filter, high pass filter, band pass filter, and band stop filter. You can try to search keywords, okay, in YouTube. High pass filter, one keyword. Low pass filter, band pass filter, and band stop filter. Find the separate video, or you can find one video explaining filtering in signal condition. If you can find one, the best one, So find at least 3 video, and share it here. So if you are under group 1 later on, share the link of the video here. Just type the link. YouTube tadi kan, contoh, example, you have YouTube. Okay, example, you have band pass filter, Okay, band pass filter. Okay, you look at, might see that, okay, this one have 2. Okay, band pass filter and band stop filter. So you go to the video, don't directly copy it, go through the content, okay, and then listen to it, explanation. If you think it's okay, then copy that, okay, put it here, group, okay, group 1, okay, group 1, what's the name? For example, Ali, okay, and then Lee, example, okay. So that one is the first video. Enter and then take another link and paste another video. 3 video. The top video is the most important that you think it's reflecting to this band pass filter. Okay. So this one is example, but of course this is only showing band pass filter and band stop filter. So find the one that have all the 4 components, low pass filter and high pass filter, okay, in a pair. So let's do the breakout session. I give you roughly about 30 minutes, okay. Okay, ada 10 orang. Tan Shin ni ada 2 okay. Right, so 4 groups, assign participant automatically. Okay, so I already assigned, so I give you 30 minutes. Okay, we will come back again at roughly about 10. Okay. Oh, sorry. Before that, okay, after you have found the video representing that, okay. Next step is that Okay, do this. Okay, like I said just now, to understand a topic, you need to capable to explain it. Okay, so one group there will be two students, at least two students. So one student need to explain two different filter. Okay, example, Shafiq discuss low pass filter and band pass filter. Okay, another one student explain about high pass filter and band pass filter. Okay, you can use the you can use a screenshot, okay, put it in a slide and then explain it, okay, in a video. So, in this video, okay, you can type that and then, okay, we do some activity, video recorder, or you can use your camera, okay, your camera, your handphone, use your handphone to record yourself explaining it, okay, and you can flip it to show the diagram and then explain it and upload it here. So you can upload it as a video. Okay. So let's look here and then video recorder or upload. You can upload the video recorder here, the recording. Alright. So student can do the activity. Okay, I will give you an example on how my previous student did that activity. Oh, not this one. Not this one. Okay. Example, the student,
Working range is
Can you hear the voice?
the scope of the system or the space
No.
restriction.
No. Oh, tak boleh. Kejap. Share. Uh, Automatically optimize. Share.
Is the capacity, so the
Can you
space
hear?
that can the system work
Yes,
in.
yes.
Okay, so this student is explaining about working range, and then he's explaining about output. What is output of a system?
The output, it is the result of our system that we want. It cannot be what we want. It depends uh, on the system, and we can.
Okay, so example is like this. Means that he do not read. Don't do example. There are some example, but I don't want to show. Example of student who actually read from my notes or read from the books. I don't want that. So you should be able to explain on your own. Okay, on your own word. What does it mean by low pass filter? Example. Okay, low pass filter. You can share. You can use a PowerPoint. Example, you find a video that explain it and then you want to use the graph or the low pass filter, then just copy paste it, put the figure here, and then you can do a screen recording. Okay, or you can just use your handphone to record it. Okay, I'm sure you should know by now how to record a screen recording. Okay, and then upload that video to this Padlet. Okay, so this will be the activity, means that by today, okay, you should be able to understand what is the low pass filter, high pass filter, band pass filter, and band stop filter. Of course, I have other activity here, so let's do that first one. Maybe not 30 minutes. I give you roughly about 20 minutes. Macam mana nak stop ni? 20 minutes. session. Okay, start now. So it's until 9:45. Eh? Tan, 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 I think you are alone in this group. So can you go leave the session? Can you leave the session? I will assign you to another group.
Okay.
Alright? Can you leave the session? Is it okay? Ask all to return breakout session assignment. Can you click leave? Okay, move stage eh. Okay, wait eh. Breakout session assignment. Okay, you go to breakouts. Another breakout eh. Testing. Okay, hi guys. Ada discuss tak ni? Are you discussing?
Doctor,
Ada
just
eh?
finding the video.
Ada.
Alright. Okay.
Yes, madam. Yes, madam.
Alright. Okay. Do you need time, extra time, since after finding the video, you need to do a recording, right? So, do you need time? If you need extra time, then maybe 9:45 tak sempat. So, until 10, is it okay?
Doktor
Is
nak tanya,
the
Yes?
video recording also doing at this time?
Yes. 2. There are 2 tasks that you need to do. First is find the recording. So basically, I think the student that find the recording, they need to do the recording lah. Okay? So this one is on how to delegate tasks among a group. Okay? Normally in a group, you have a leader, ketua So ketua ni, dia kena lead lah. And leading is that assign lah. So tadi ada berapa? Ada 4 kan? Ada low pass filter, ada high pass filter, band pass filter dengan band stop filter. Okay. So that leader assign lah. Okay, Divin, you buat yang ni. Chu, you buat yang ni. Saya, Arifah, kalau you ketua, you buat yang ni. Okay, cari task tu, dah cari 3 for each the video tu. Each component tadi kan, low pass filter ada 3 video. Based on 3 video, go through very fast. You know that you can speed up the video kan. Guna berapa kali, 1.5 times ke and so on. Speed up video, then do a recording. Recording shouldn't be long Recording tu dalam 1 minit, 2 minit dah lah. Jangan panjang-panjang sangat. Nak explain low pass filter tu, it should be very short Okay, so clear?
Sir, the video recording is our face also need to insert
No need.
or
No need.
outside? No need.
No need your face. If you want to put your face pun okay. But at least you should have a diagram to explain kan. Normally you need to explain with a diagram. And then your voice should be enough lah. But if you can add your face inside, if you have you have a video cam or laptop, you ada laptop yang ada video cam, so tak ada masalah. You can video record your face also. So up to you. Okay.
Madam,
So yes.
can we use the Zoom app for recording the video?
Yeah, sure. You can use Zoom. Because Zoom, you can just open Zoom and then do recording. Then you have the recording, right? And then you upload that. It's up to you, the creativity. You can use Zoom. You can use other recording apps. For example, before this, I normally use the free cam ni dia free punya version lah. Maknanya dia boleh record non-limited time So you boleh guna free cam contoh, ataupun you can use Zoom pun boleh juga, tak ada masalah. Up to you. Or you can use your handphone. The very simple one is use your handphone to record. Okay. So continue Alright. Until 10 2 tasks.
Yeah, doctor.
Okay, madam.
Okay. Hi guys. Okay. Hello.
Hello?
Okay. Just to inform you guys. Okay, the task that you should be discussing in that just now I informed group 1. It's until 10 And what you should do is that there are 2 tasks kan just now. One is to find the video for each of the filter tadi ada 3. Okay. And then record the video. Okay. So you should by now ada dah assign lah siapa yang kena record video yang mana and so on. It's a group task. So means that bukannya seorang pergi record untuk semua. Delegate to each one of you semua kena ada recording. Alright. So until 10 I give the extension. Any question tak?
Yang record video tu yang task 2 tu
Ya, ya. Ya, kan dalam Padlet tu ada 2 kan? Sekejap Sekejap share. Mana? Cuba buka. Tutup balik yang ni. Yang tu. Tutup yang kat P tu. Oh, itu you dah buat. Okay. Kenapa you ambil video I? Okay, yang ini, okay, yang ni, dua-dua tu. Week 5, yang itu video tu, lagi satu yang record tu. So, 2 task lah until 10 Alright?
Betul.
Alright.
Ente je ke bawah.
Okay guys, task is until 10. I already extended inform tadi pada yang ada group. And the task is that ada 2 task One is to find the video. Lagi satu adalah to do the recording. So ada 2 tau.
Oh,
Sampai pukul 10.
Terus buat recording betul?
Ya.
Alamak.
Terus buat recording So saya bagi masa sampai pukul 10 lah. So student, you guys kena delegate task lah. Patutnya dalam group macam ni, discussion macam ni kan. You ada ketua seorang. Ketua ni dia lah tukang assign dia. You lead. You nak tunjukkan yang you capable. Mungkin ada dalam 3 orang ni, seorang extrovert. Tahu kan extrovert apa kan? Extrovert ni yang suka bercakap lah. Okay, so dia suka bercakap. So dia akan delegatekan task. Okay, ataupun introvert pun tak ada masalah juga. Dia boleh delegate task. So, contohlah, Syafiq ketua. Okay, so Syafiq akan sign, okay, yang low pass filter saya buat. Tan, you buat high pass filter. Tashini, you buat bandpass filter dengan band stop filter. Contoh, okay. So, tadi Tashini dah buat 2 kan? Okay, so recording tadi pun kena delegate accordingly lah. Mungkin Syafiq kena buat recording 2 ke macam tu. So, delegate accordingly. Alright. So, sampai pukul 10
Okay. Yang tanya soalan tu ni. Yalah, 1 minute.
Kejap, tengah recording. Dia re-recording. Hmm.
Get vaccine-related information on Google.
Lowest price guaranteed on Lazada. Add to cart now.
So we've looked at frequency content. I'm going to take a look for when you just need to remove a whole bunch of low frequency. Remove the high frequency, cut away, and then we just had that area. So the cut filter more if we're octave, but normally this is fixed in
In this video, we're going to talk about bandpass frequencies. Would fit the description of these two types. Defined within a certain range, they allow through the circuit. All the low-level frequencies and high-level frequencies get filtered out. The bandstop filter is the reverse. The low-level frequencies and the high-level frequencies are allowed to pass through the circuit, but mid-level frequencies within its band are filtered out. Now let's talk about some circuits is the reverse. Mid-level frequencies, defined within a certain range, they allow through the circuit. All the low-level frequencies and high-level frequencies get filtered out. The bandstop filter is the reverse. The low-level frequencies and the high-level frequencies are allowed to pass through the circuit, but the mid-level frequencies within its band are filtered out. Now let's talk about some circuits that would fit the description of these two types of filters. So first, we're going to focus on the bandpass filter. And there's two RLC circuits that can work as a bandpass filter. Here's one of them. We're going to have a resistor and an inductor that's parallel to a capacitor. So this is a parallel RLC circuit, since the inductor and the capacitor are parallel to each other. So this is R, L, and C. Now, before we discuss this circuit, there's some things that you want to keep in mind. When you have an inductor, inductors allow low-level frequencies to pass through without
and so on. So before, I was not thinking about research anymore. I was thinking about saving my life. DC or DAC. So if you have a research and mechanical actuation, okay, so it's still okay. Hi guys. Oh sorry. Already back. Have you finished the task? Guys?
Ya, aduh.
Selesai dah?
InsyaAllah
Share.
dah.
Share. Nampak skrin saya tak? Tadi
Nampak.
saya salah share screen You guys pun tak ada komen apa-apa. Saya salah share another screen. Okay. Okay. So right. Okay. So what you have learned? What do you think? Is it useful, the session? Okay, let me just play. Okay, okay, low pass filter group 1, low band stop filter. Group 2, high pass filter, low pass and high pass filter. And this one apa Arifah, band pass filter and band stop filter Okay, so group 1, I think we have 3 group, right? Group 4 Group 4 yang mana Group 1. Ni siapa? Syafiq ke? Yang bawah ni. Tak ada nama lah. Saya tak tahu. Anonymous. Nama pun tak tahu siapa. Syafiq, you group mana?
Group 4. Yang tadi
Boleh
saya
tak?
buat lagi satu tu. Ada low dengan ni.
Group 4. Ni. Group 4.
Saya buat balik. Malas nak padan yang tu.
Okay. Alright. So we have 3 groups. So basically, let me just look at the low pass filter So low pass filter group 4 ni Saya playkan tengok explanation okay ke tak. Mana ni?
Hello, Assalamualaikum. Okay. This is low pass filter and high pass filter. Okay, for low pass filter, low pass filter adalah penafisan yang menghantar isyarat dengan frekuensi yang lebih rendah daripada frekuensi cut off yang dipilih dan akan melemahkan isyarat frekuensi yang lebih tinggi daripada frekuensi cut off. Manakala untuk frekuensi untuk high pass filter adalah penapis elektronik yang menghantar isyarat dengan frekuensi yang lebih tinggi daripada frekuensi cut off tertentu dan melemahkan isyarat dengan frekuensi yang lebih rendah daripada frekuensi cut off.
Okay. So that one is group 4 So let me look at another group. Low pass filter. Ni group 1 ni lain Ni deviant So okay.
Hello and a very good day to my lecturer, my fellow friends. Okay, my name is Divyan Rajkumar from the breakout section 1, and I'd like to explain about low pass filter.
Can you
Okay,
actually hear
basically, low pass filter,
the
as we
sound?
know, is allow frequencies from 0 up to some frequencies to pass,
Yes,
Okay.
doctor.
which also means that it also smoothen or denoise the frequencies.
Mhm.
In other words, it also takes the high frequencies to smoothen them, and also which allows the low frequencies to pass as normal. If I said that, it will pass the low frequencies and also it will attenuate the high frequencies, which is the same. And based to be tested on a practical thing, when the high frequencies is applied on the certain element, the signal will become less and less to be detected. So as the frequencies decreases or the frequencies is applied is less, the signal will become higher or higher chance to be detected. Okay, that's all for today. Thank you.
Okay. So basically, I think most of you get the idea. So let me just explain a bit. Okay, that one was a low pass filter and high pass filter. Okay, let me look at the band pass and band stop. Band stop filter. Okay. Yang ni siapa Sorry, I tak tahu nama Nama tak ada dalam ni. Siapa ni?
Band stop filter. The frequency low level and high level in band stop filter is able to pass through the circuit while the main frequency is blocked. So it will show the waveform that the frequency low level and frequency high level is high while the frequency main is low.
Okay, that one is band stop Yang ni high pass filter. Band stop. Ni okay. Ada band stop dengan band pass
For the band pass filter, when the low pass filter cascade with the high pass, then we will get the overlapping region here, and the overlapping region here. This is how we get the band pass filter, and this is.
Kenapa?
For the band pass filter, it is actually when the low pass filter cascade with the high pass, then we will get the overlapping region here, and the overlapping region here. This is how we get the band pass filter, and this is also can call as a bandwidth. If we look at the graph here, we will get the two frequency, which is frequency 1 and frequency 2. Then we will know that the region here is the band pass filter, and the band stop filter, and also we can call the reject filter, and it is actually the response between the two, which is the low pass filter and the high pass filter. And then we will adding the two filter here, and then we will get the graph, which is the band stop filter. For the band pass filter,
Okay, so let me just explain a bit. Maybe you get the idea what does it mean by band pass, low pass filter, and so on Not this slide, another slide. Okay, this one So this one is not in the original slide, but I'm just going to share. Can you see my screen right now? So if you look at this diagram okay. Before we can go and directly understand about what is actually filtering filtering the one that you learned just now is filtering the frequency so high frequency, low frequency basically. Okay, so based on that you have you know that there are 4 types of filter. We have the low pass filter, we have the high pass filter, okay, we have the band stop filter, and we have the band pass filter. Okay, so what does it mean by that? Means that you are having 2 different frequency. Means that the frequency that you want to keep and the frequency that you want to remove. Okay, and why you need to remove that frequency is that maybe that frequency include noises. Okay, so I saw that in the first task is that student already get the video related to the each of the filter. Okay, so you can this is in a way I hope that student get the video with different link. So you guys can go through your friend's video and do make it as a revision. So different group have different link. So before we go to that, so what does it mean by frequency? High frequency and low frequency. So if you look at this graph, we have three types of graph right now. Okay, and the one that you see on the top one, graph number 1, is basically a signal, sine wave signal, giving a high frequency. So how do you get the high frequency? Well, you just use a simple equation. So you know that time is time of the cycle, one cycle. So this is time, okay, T naught, time. Okay, so one cycle, and from there you can calculate what is the frequency F. So F is 1 over T. So basically, when you look at signal 1, 2, 3, signal 1 is signal with has high frequency. Okay, and the third signal is the signal with low frequency. Okay, having said that, if you have these three signals combined, okay, let's say that I'm giving you an example. This example is actually when I'm teaching signal system. Signal system, student will learn this subject in second year, second sem. Okay, signal system is discussing about signals, sine wave signal, cosine wave signal, rectangular signal, triangle signals, and also filtering using Fourier transform, Fourier coefficient, okay, Fourier series, and so on. So in that subject is that basically students are going to learn about two types of domain, time domain and frequency domain. Okay, so talking about frequency domain, also you will learn later on how to filter, okay, the signal using Fourier series and Fourier transform. But I'm going to give you an idea. So you look at this example. You see that this example is we have a ship, okay, and there is actually, if you look at this, is you see that there's a wave, a high wave. This wave is
Doktor lagging ke? Doktor lagging.
Lagging ke? Tak tahu. I tak lagging lah sebab I tengah bercakap. Anyone else? Anyone else?
No lagging.
No, all fine.
No,
Okay.
fine.
Everybody fine except Syafiq tadi. Okay. Maybe you punya internet kot, tapi tak apa. This is recorded there. So I continue. Can I continue? So from from this waveform, you see that example of tsunami. Tsunami. Okay, you have a tsunami, which is tsunami is comprised of multiple waves combined. Then you will have a tsunami. Why? Because you have the earthquake in the middle of the sea, the ocean. The ocean. Okay, and then you will give a tremor. Tremor means that wave. Okay, first wave, second wave, third wave, and when all of these waves combine, then it will become a large tsunami. So basically, I actually shared to my student. I tried to find the video. Okay, previously I do share a video of the tsunami in my signal system class. Give me 1 minute to find the video. Have you actually seen a video of a tsunami in Tohoku earthquake 2011? Have you seen the video? You haven't seen it. Okay.
Yeah.
So if you haven't seen it, then this should be interesting. Tohoku earthquake happened in 2011. I was there in Japan. I was doing my PhD 2011. So I really can remember what happened. I remember what happened because I was there in Tokyo and it was skala Richter 5. In Tohoku it was 11. It was 9. So this one is a example of tsunami. So let's look at the video.
関東の一部の県庁所では津波の観測データが入らなくなり、現在津波の高さが大津波よりまた
This video.
岸を向けてまいります。大きな津波が迫っています。まもなく捉えました。
Okay, so can you listen to the video? Okay, so you see that actually the person is saying that tsunami is coming, the first wave. Oki is large. In Japan means that Oki is large. So he's saying that the wave is coming. Oki tsunami lah, large tsunami is coming. So
Nampak folder ni, doktor?
you
Ada
nampak apa?
bunyi je. Video tak ada.
We just see the folder.
Okay, saya salah share. Itulah saya salah share. Sorry. Okay. Nampak tak video? Nampak tak?
Okay, nampak.
Okay. Tadi salah video. Okay. Start balik. So, he's saying that the tsunami is big, Tsunami Oki. So, it's coming to the shore. That time. So, you see that this one is the first tsunami coming in. Okay. So, and you can see that after that first tsunami hit, there is a second and third tsunami coming in, Okay, it might look, dia cakap sampan yompan, maksudnya sampan tu 3, third tsunami, fourth tsunami coming in lah. So basically combination of all this, you see, okay, this is what happened to Tohoku. Okay, the tsunami is hitting the shore lah, basically the shoreline. And I actually watched it live on TV in Japan that time, because it took like about, I think, 10 minutes after the earthquake happened. They have the warning, even at my UC, they have a warning of, because it's near to the Yokohama. Yokohama is Yokohama Bay. So dia, you know, Japan ni macam pulau so dia sekeliling dia adalah laut. So this is what happened to Japan in 2011 and March. It was mass destruction. Okay, so having said that, I think you can just Google the video later on. Okay, and having said that, okay, it's interesting to actually combine that example to the tsunami, because let's look at this example. When we talk about signal, you have signal 1 here. You know, the first signal just now, first waveform, second, third, and combination of all these signals, you will get a large wave like this. So this is what we call as the tsunami. And different wave, okay, you have different frequency. For example, you have frequency 1, frequency 2, frequency 3, and frequency 4. So imagine that you have signals, okay? Signals that you capture from a device, and you found out that there are some signal that you don't want it. You don't want the high frequency signals, okay? So you want to remove that signal. So that's where you want, for example, let's say that the frequency that you do not want is the high frequency signal. So you are going to use the low pass filter. Okay, so imagine that this is the signal that you capture from, for example, from a sensor. From sensor, you have the signal. It should be reading like this, but sometimes it have spike. Okay, so you want to remove this spike. Okay, this spike, how do you actually capture the frequency? So how to capture is that by using the same method like this. Okay, find out what are the spikes. So example that this spike, the spike here, okay, what is the time for one cycle, and from there you can get the frequency. Okay, from that frequency, then you are going to use the low pass filter. Okay, low pass filter is something like this kan tadi, low pass filter. So the high frequency, maybe the cut off frequency that you want to cut off is at this frequency, for example, frequency at 10, F10. So the frequency is at this point, F10. So that's where you're going to use the low pass filter to cut off this frequency. So frequency normally will be identified, plotted into terms like this. You have the frequency. Okay. Let's say that we have here F1, F2, F3, F4, F5. So you want to cut off F10. So you're going to design the low pass filter in such a way that when you have this signal, the signal, when you multiply with the low pass filter, you will get 0. Means that this F10 will be removed lah. Okay. So it's like a multiplication of a signal. You have one signal, this frequency, multiply by a signal that is 0. So when you multiply this signal plus this signal, what you get? You get 0. So that's why it can be removed. The F10 value can be removed. Okay. So having said that, okay, if you can imagine that, so that's where you can use the frequency. You know which frequency that you want to remove. So you want to remove the high frequency. Then you need to design a low pass filter. If you want to remove the low frequency, then you need to use the high pass filter. Okay. So I think most of you understood that. Okay, and how to design the low pass filter, high pass filter later in another subject. You will learn the detail on that. Okay. So let's look at the amplification also. This one, please make it as a just a task, simple task. Don't don't take it as the task that I give you is burden. Take it as a way that you study or you do a revision for the class. So next is that find the recording. Okay, find the best video similar to what you have done for the filter. Find the video that represent the amplifier. So you know that in my notes there are a few amplifier. You have the non-inverting amplifier. You have the inverting amplifier and so on. Okay, so find the amplifier and then related video and share it here. Okay, that one will be individual work. So share it here. And then next is that on Zener Diode. Okay, Zener Diode, even though I have shared to you in my ULearn, so try to find another video. I noticed that some students use my video, the same link that I shared to you in ULearn. So try to find a different video. Okay, because there are lots of video. So don't use the video that I shared. Use a different link, video link. Okay. And lastly is that draw the block diagram. So based on number 5 here, the Zener Diode is you need to do a recording like what you did here. Record and explain how you do the Zener Diode. So I would prefer student do like, for example, like siapa ni tadi Ni siapa? Tak nampak nama Siapa ni? Ni siapa? Anonymous ni?
Arifah punya.
Arifah minta letak nama I tak tahu siapa. Arifah ke group 4 ni pun siapa nama. Buat macam tadi. Kan tadi ada letak nama. Lepas tu dia tak pandai dah. Tak ada example dah tak pandai student they don't take it as example, good example So make sure everything put your name I cannot macam ni. Chu ni letak nama. So use the video explain macam ni Louis ada explain guna diagram ke?
Good morning everyone, my name is Lu Jingkai and today I want to present about the high pass filter which is HPF. The high pass filter is used to remove lower frequency and allow high frequency signal to pass through the circuit.
Okay. Alright. So, I prefer I think the best one that I see so far is example dividend. Very simple. He take just the example from textbook and explain it. Or Arifah pun sama. Arifah pun okay. And then Syafiq pun okay. Just like Syafiq. I prefer English most of the time because in exam English So I marking dalam English. So bahasa Melayu ni kalau tersilap susah juga nanti. So better in English. Alright, so nanti untuk Zener Diode ni please make a recording and explain. And I prefer that you explain using a diagram. Diagram and explain it. Muka you tak ada pun tak apa. Yang penting ada diagram and your voice. Okay. So back again to the solution, the solution to the problem. Okay. Can I have volunteer for problem number 1 to explain the answer for the first part? No. This one. Okay, can I have the volunteer for A? Question A. Everybody need to actually present later on, because I'm going to tick who presented. So those who presented can skip for the next task. So volunteer for A. Explain 5 different functions of signal conditioning. What you need to do is that you need to present what you have uploaded. Okay, explain and present. Share your screen and present it. Yeah? No one? Kelas online I memang banyak discussion communication macam ni. I don't prefer to I talk on my own because I don't know student what you are doing. Okay, so siapa nak volunteer? Okay, doktor tu Syafiq ke apa? Kalau nak volunteer, share screen.
Jadi.
Nak volunteer, share screen je terus. Tak perlu tunggu saya. Share screen. Saya akan take note siapa yang present siapa? Syafiq Syafiq. Okay. 11. Syafiq boleh juga ambil daripada, kalau you upload daripada you punya komputer kan, mesti you ada copy raw kan. You share yang you punya raw copy pun boleh.
Daripada handphone. Daripada handphone.
Oh, daripada handphone. Okay. Boleh? Besarkan sikit Syafiq. Kenapa yang belah kanan tu kosong
Yep.
Kenapa kanan tu?
Belah kanan mana kosong?
Entah, skrin saya tengok separuh je. Okay, ni dah okay. Okay,
sebab saya pilih dia tingkap.
Oh. Okay.
Okay. Number yang A, protection
A
to prevent damage, example fuse or current limit. Second application is an electronic device that can increase the power of a signal. Dalam bentuk kalau dalam bentuk graf dia masa kali voltan atau current masa kali amplitude. Okay, noise reduction is the process of removing noise from a signal. Contoh macam ni, graf dia ada noise gitu, dia pakai filter nanti dia akan jadi clear je punya graf dia.
So soalan saya, how do you actually remove the noise? How do you know the frequency of that noise, Syafiq? Tadi saya dah explain kan macam mana you nak calculate noise frequency tu.
Macam mana tadi?
Macam mana? You punya gambar ni dah okay. I nampak okay. You ada satu signal yang belah kiri tu yang ada signal sine wave. Tapi dia ada noise kan pada signal tu. And then lepas you ada filter, dia jadi clean. So my question is that, how do you find the frequency of that noise? Macam mana tadi?
Macam mana tadi?
Siapa boleh tolong Syafiq? Anyone can help Syafiq?
Use flow rate. Apa dia ni?
Anyone can help Syafiq? Talian Hayat cepat tolong Syafiq.
Doctor, what just now
yes.
the question of the doctor?
Pardon?
What is the question of doctor?
My question. Okay, my question is... Alamak, kenapa ni? Okay, my question is that, okay, Shafiq is explaining about the noise reduction, instead filtering lah. Okay, so removing noise, So you the left signal shows a signal, sine wave signal that have noises. Okay, nampak tak yang noise tu kan? So and then the right signal is after removing the noise, means that dah buat low pass filter lah tu. So dia removekan noise high frequency tu. Okay, so my question is that, how do you calculate the frequency of the noise? Yalah, it's but you want to design the low pass filter, right? So you need to know what is the frequency to be removed. So how do you calculate the frequency of the noise? Tadi I ada explain tadi.
Oh, yang formula, pakai formula tu
Tadi saya ada tunjukkan gambar yang signal tu kan, macam mana nak frequency find the signal. Ada tak? Anyone? Tak ada. Lambatlah korang. Tak apalah. Saya explain. Tak habis kelas sekarang. Okay. Mana tadi? Screen saya ni. Bagi tahu saya kalau nampak screen Saya takut saya salah share. Okay, nampak tak whiteboard? Nampak? Okay. Ni whiteboard. Wah, kena. Okay lah, memang nak whiteboard kan. So, Syafiq punya signal tadi, dia ada noise ni. Ni, noise kan? Noise. Okay. So, noise ni dia ada frekuensi dia sendiri kalau you perasan. Dia ada noise the same frequency kan? So, imagine that ni frekuensi dia. So, tadi kan saya dah explain. Cara untuk nak cari frekuensi dia adalah one cycle kan? Cari dia punya T. Kan? Then from T you boleh dapatkan frekuensi. So inilah frekuensi untuk yang you nak remove dia supaya you boleh dapat clean signal. So this frequency it compare, okay, you know that you have a signal macam ni. Lagi satu you have signal with have this frequency. So of course this signal is low frequency. Okay, low frequency. And then the noise is the high frequency. So, basically, you need to use low pass filter kan? Yang low frequency tadi yang kat sini. High frequency yang you nak remove. So, after you use the low pass filter, then you will get this signal. Okay? Boleh faham tak? You yang buat gambar ni So, I harap you faham lah. Okay? Faham tak? Everybody? Hello? I tak tahu ada orang faham ke tak sebab tak ada orang menjawab. Faham? Okay, so... Okay, cepat. Syafiq lagi? Next.
Yep. Okay. Number 4, signal manipulation. Use the signal processing function for analyzing, interpret and manipulate analog and digital signal.
Okay. Next.
Conversion function convert a value from one data type to another.
Example?
Example.
Conversion of what? Conversion of analog to digital, digital to analog kan? So need to be detailed when you explain. I think student do not get the idea kot. The one that I share to you in the ULearn. Okay, in ULearn. Okay, in ULearn. Okay, you see that I have the converter, amplifier, Okay, filtering, multiplexer, that card. And also in the notes, in the notes, okay, if you look at the notes, okay, you will see that explanation of each of the component. And also in this part, I talk about the requirement of A to D, okay, amplification and so on. So 5 function is where I have discussed this one, this main one. Okay, 5 function. Okay, so this one is the common function, and for a problem, it may require 4 different signal conditioning, maybe, or you might need only 2, or you need only 3, depending on the problem. Okay, so thank you, Shafiq. Almost correct, but I would say the explanation is not detailed. It's very general. Dia assuming like you boleh goreng lah. You goreng, and then you assume you can get marks. But by having that explanation, very general explanation, you won't get full mark. Okay, to get a full mark, you need to be detailed. When you talk about conversion, you need to explain what type of conversion. Analog to digital. What is it? Digital to analog. What does it mean? Okay, the best way is that also to add in a diagram. Okay, so
Kena
that one.
terang dua-dua gitu lah kalau ada dua jenis.
Kena terangkan. Okay, the more detail you explain, the more marks. The general you explain, you dapat 1 je lah kot daripada 10. Okay, so this is how lecturer give marks. Okay, okay, next. Okay, thank you, Shafiq. So next is discuss the signal requirement and outline solution to input the signal from electromagnetic sensor to computer. So, okay, may I have one student to explain that very fast? We have only 10 minutes. Cepat-cepat volunteer. Ya, boleh. Siapa? Divian. Okay, Divian.
Dr. Chu.
Oh, Chu. Okay. Share your screen. Chu. 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 Semua orang akan ada turn dia. So, you terlepas hari ni, besok ada lagi. Kita ada 14 minggu nanti. Kita jumpa. Okay. So, best to offer now. Okay, Chu. Let's look at okay, alright, ini.
Yes.
Okay, you may start.
Okay, the next question is discuss signal conditioning requirements and the outline solution to input signal from the electromagnetic sensor to a computer.
Alright.
So there is the block diagram. So first, the electromagnetic wave signal is coming in, and the electromagnetic sensor is detect. And after that, is passed to the signal conditioning, which is amplifier, filter, and analog processing. So that it pass through the multiplexer, which collect all the analog, then change the analog to digital conversion, then to allow the computer to read and display on the screen. Okay, so we want to do the response. So we need to digital to analog back the conversions, and then to let the LED emit the light, so that we know that they have a explosion.
Okay, alright. Quite good, your explanation. Okay, alright. Thank you, Chu. So let me just share my answer so that you can compare. Okay. My answer is not the script. Sometimes students do better answer. So it's not that you need to. My answer is the best. Sometimes student answer is much more better. Okay, let's look at this. This one is the script. Okay, so the question is that discuss signal condition requirement and outline the solution to input the signal from electromagnetic sensor to a computer. So basically, in the previous yesterday's slide, I explained about the outline. Outline ni maksudnya block diagram lah. So and the requirement is that for the problem is that the signal is weak, kan? Weak, you need amplification. Okay, so the signal has noises, so you need filtering. and the signal is analog, therefore you need to convert it to digital to receive it. So outline is from sensor to a computer. So you have sensor at the as the input, okay, to the system, and the computer is at the end part to display or to give a reading to the LED. Assuming like what Chu shared just now. So very good, because I do not add LED, but he added that. So that's good. So how do you actually outline it? So first of all, okay, so you need a protection, because most of the time, like I mentioned yesterday, all signals, and if you go to the video of a Zener Diode, all a circuit at least need a protection. Okay, so you need the Zener Diode as a protection. Okay, and for the amplification is that a very simple one that you need to have is that a non-inverting op-amp. Okay, to amplify the signal because the signal is weak. Okay, so protection is the first one. Second is the amplification. And then, because of the signal that is captured has a lot of noise, okay, you can actually filter it. For example, okay, signal has noises, so filter it at a frequency 50 Hertz. Okay, example, and convert it to. Sorry, this one is low pass filter. Okay, I cannot edit that. So that one is low pass filter. And last is to convert from the analog to digital, because you are actually capturing it to computer and you want to display it. Okay, so you want to have an analog to digital. So basically what Chu shared just now was a very good example of answer. Okay, so if I were to give marks, then you get almost full marks lah, because all have the component of the signal just now. Okay, so lastly, the last question. Okay, design a circuit to amplify the output signal 1000 times the original value. So basically, you need a non-inverting amplifier. Okay, so any volunteer? This should be very fast. You need to use the equation. Okay, any volunteer? Any volunteer?
Madam?
Devian. Devian,
Yes,
yeah?
madam.
Okay, can you share?
I would like to volunteer, but I don't know my answer is correct or not.
It's okay. It's better incorrect now than incorrect in the exam. Okay, so it's okay. Just share, so that I want to know, student, did you get the idea on how to calculate? Okay. Okay.
Wait, madam, sharing my screen. Yes.
So when it asks you to design a circuit, basically, okay, you refer to the non-inverting op-amp, okay, because you don't want an inverted value. You want if it's positive, then you want the amplification in positive manner. So you use the non-inverting op-amp. Okay, alright. So can you explain a bit?
Actually, that question says design a circuit to amplify the output signal 1000 times. So this is what I have drawn, madam. So this is the amplifier.
Which notes do you refer? Did you refer from the textbook?
No, madam. But actually, I've searched in Google for some resources.
Okay. So if you refer to the textbook, the notes that I shared in the textbook, you should be able to refer to the non-inverting amplifier. Okay, it looks but you get the idea lah. Means that to answer this question, you need to draw out the circuit, circuit like this. So you have the op-amp. Just that I do not know what is the value of the R that you use. For example, you have 4R. You have 2, 4, 6, 6 R value, resistance value. But what are the value of that R? So when you say design a circuit, means that you need to determine what is the value for R1 and R2. Okay, so Devian, if I were to give marks, you won't get full marks because you don't have the value of R value, and you don't give the equation, how to calculate for the non-inverting non-inverting op-amp. So, and even I do not know what type of op-amp you are using. Are you using a inverting op-amp? Are you using an non-inverting op-amp? So you didn't mention that. Okay, so all of those things have marks. So let me just share my answer. Okay, so this is the how you should answer. You draw out the non-inverting op-amp. Okay, this is non-inverting op-amp. It's exactly like in the textbook. Okay, so you have R1, R2, and then you have the V-in, which is assuming that, okay, since it doesn't give you any value of what is the input V-in. So let's say that it's very small, the signal that is captured 1 volt. So 1 volt. And you want to actually amplify it 1000 volts. So assuming that at this point, okay, so you have here 1 volt, and then you want it to have 1000 volt amplification. So you are using the non-inverting op-amp over here. Okay, so this circuit is actually in your textbook. Okay, so how to calculate for the value for R1 and R2? Okay, so it's also in the textbook. So voltage gain. So basically, you know that when you have a non-inverting op-amp, means that it's an op-amp that gives you a positive value. So if you have 1 volt here, then the output should be plus 1000 volt. So that what it means lah, non-inverting. So if it's inverting, means that if you have 1 volt here, the output is minus 1000 volt. But we don't want that. So we are not using the inverting op-amp. We are using the non-inverting op-amp. Okay. So if I were to draw out okay, this is op-amp example. This is the output 1000 volt. This is the input 1 volt. So basically what you want to find is what is the gain of the op-amp. So what is the voltage gain? So voltage gain is given by the equation. Okay. So where's the equation? It's in the textbook. Sorry, I take your a few more minutes. Sorry if you have class. Let me just click that. Okay, you go to the notes. Okay, you should be able to find the op-amp, non-inverting amplifier. Okay, this one non-inverting amplifier. So it's given by this one. R1 Vx. Vx is the input over V out. R1 over R1 plus R2. So you get the voltage gain of the circuit V out over V in lah. So it's given by this equation. So I'm using that equation. Okay. To calculate what is the value of V out over V in. So you know the value of what is V out? 1000. V in is 1. Then you need to determine what R1 and R2. So let's just assume that R1 is, for example, 50 ohm. So just calculate what is R2. So you may assume here. Okay. So R1 is 50 ohm. R2 is what? So calculate that. Then your answer should be R1 equal to what? R2 equal to what? So this one should be, if you answer it correctly, then you will get full marks. Okay. So that's the idea, okay, behind the op-amp, okay, non-inverting amplifier. So basically, when we talk about op-amp, it's basically a gain value, a gain. You want to increase the input to a certain gain, so you use op-amp. But nowadays, for equipment, we can actually buy an amplifier that is ready. So you just put in the input of the voltage to that amplifier, then it will give you the output that you need. For example, you want to amplify it to 1000 volt. So you can actually use the amplifier. It's a one machine. Okay. So we have that in our lab. So that is amplifier. Okay. So let me just share to you. BEKM. Okay, how does an amplifier look like? I'm just going to skip this. I'm going to show you the amplifier. Okay. Okay, if you see this, this slide, oh, sorry. Okay, this slide, you can see that this one is an actuator. But I'm not going to show you this. I want to show you these two blocks. Okay, it's a high current amplifier. It's going to amplify the current. For example, the current from, we want to actually give a high current to the actuator because it's electromagnetic actuator. So you want to give it to 3 amp. So this amplifier will directly, we can actually set it what are the value of output current from the amplifier. Okay, so this one is example of a more sophisticated op-amp lah, basically, an amplifier. And this high current amplifier, it costs, I bought it about 10,000 ringgit Malaysia. So amplifier is not cheap, it's costly. So op-amp is because if you see op-amp, it can actually amplify very small gain value. So I think that will be all for today class. And but before we stop, okay, let me just share to you. Okay, for chapter 3, I think we are finished on chapter 3. Okay, you can go through again what you have. If you didn't go through the video, just simply go through without understanding it. Just go through again. Then make sure that you do the self-assessment on a quiz. Okay, and then, okay, chapter 4, don't forget in the synchronized class is that for today is that it's going to be asynchronized. Means that you're going to learn, go through the video for the synchronized class. Okay, learning curve here. So recorded video that I have done. Okay, go to that video. And then also a video of Andon system is basically a displacement system style. Okay, and it's being used in lots of company, industry and manufacturing industry. So it's a use Andon system. So looks at what are types of Andon system, and I'm sure you have seen it before during your LI, Latin industry, before this at the Polytechnic. Okay. And another example is a moving coil, a display. Okay, so example, this moving coil you can see in measuring weight measuring, mesin penimbang lah, weight measuring. So how it actually goes from 0 to 100 kilogram, example. Okay, go through that video. And after this, I think I will, but not this week. Next week, you will do the self-assessment for chapter 4 on data presentation. Okay, so any question before we finish class?
Saya lupa
okay.
attendance.
Oh, okay. Maaf lah, tak dapat nak buat apa. Okay, sebab saya tak boleh buat apa. Saya tak boleh nak buka sistem. Dia dah memang lock 8 to 9. 8 to 11. Okay, next time, make sure to tick. Okay. Pukul 9 tu, ini pun saya tak pasti. Mesti nak kena cerita satu-satu lah kan. Saya macam malas nak cerita lah. Because you are not kids, budak kecil. You are university student. Okay, but anyway, since ramai yang jadi macam ni kan, tak buat attendance semua. What you need to do is that, before class 9, while waiting for me to enter, open ULearn, then directly at 9, click attendance. Okay, so open the ULearn before class. Then stand by, 9, tick. Okay, so that you don't have any problem that saying lupa nak attendance. Okay, sebab I tak boleh buka. Maaf, it's already locked in the system. I already make attendance 9 to 11. And it's only open during class. So, that'll be all. Any question other than related to class? Any question? No? Okay, no?
Yang untuk Padlet tu ada ni ke? Sampai bila?
Padlet tu basically Padlet, okay, Padlet, the task tu it's until the one that video find the best video tu video lah macam tadi you buat dalam group up dalam session tadi. Okay, macam ni lah, sebenarnya saya bukan nak paksa student buat benda ni. Tak ada markah. Tapi it's for your own good. Okay? If you do all this, you will get A. Kalau you tak nak buat pun tak ada masalah. Tapi, I'm sure you won't get an A for this subject. Sebab you don't do a self-learning. Okay? So, the deadline for all this in Padlet, normally I open 1 week until the next week. And next week, I will go through the video. Okay? And based on the feedback form in the ULearn, also, I will look at if student mention if they don't understand certain topics. Then I will explain again. Okay? Or we do some activity to enhance student understanding like today. Because student mentioned that don't know about filtering. Okay? Do not know about amplification just now. So I think the amplification I already explained in the problem just now. So should be clearer. So other than that, don't worry. In the ULearn feedback, it's not for me to give marks to your feedback. It's for you to learn, and I will have to explain it. Okay, in the next class. Okay, so did I answer the question to? I think the feedback was from siapa yang bagi feedback on class hari tu? Semalam punya kelas. Did I answer my question to Nick dengan Divian? Nick, about the filtering?
Yes, Doctor.
Yes, okay. Okay, Divian, did I answer about the amplifier just now?
Yes, madam. Yes, madam.
Yes, okay. Alright, good. So, anyway, you can just comment here if you don't understand the topic, then I try to explain it again in the next class, next lessons. Okay, that will be all, So, don't forget to do the feedback. I open it until next week, 7 November. So, that will be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Waalaikumsalam.